Okay, cool. All right, everybody. Welcome to my talk, Waking Up the Data Engineer in You. So I'm Jared Atkinson. Quick bio slide because I don't have much time, but I'm the technical director of adversary detection at SpectreOps. Do a lot of PowerShell development. I'm really good at Minesweeper on Windows, the old school game. 56 seconds on expert if anybody wants to challenge me is my record. Used to be in the Air Force, that kind of thing. So what I'm planning on talking about today is at SpectreOps, one of the things that we get to do is teach training classes. And one of the training classes that I'm involved in really focuses on detection engineering, right? So how do you build robust detections to focus on technique level attacks as opposed to very naive detections that would focus on things like hashes, URLs, that type of thing. So how do we build really robust detections? In our experience as instructors, oftentimes students teach us as much as we're teaching them, right? And so we get to learn from kind of the different things that they're trying that we had never considered. And so through the process of this talk, I hope to kind of like share with you some of the things that I learned and how like that student-instructor relationship really helps to kind of inform some of the detection engineering efforts that we do and kind of reinforce the idea of how you can leverage an understanding of the data or telemetry that you're collecting to really understand better ways of building detections. Okay, so just kind of to set the stage of, I'm going to tell a story about this interaction with a student, and then I'm going to talk about some strategies that you can use to kind of build on it, right? So in the class, one of the things that we do is we talk about, how do you select the different attack technique that you're focusing on to build a detection. So you're building a hypothesis which says, I think that the attacker is going to do X attack technique, right? And so I'm going to build a detection for that. So one of the ways that we present to the students is to use threat intelligence, right? And so this is just a snippet from a threat intelligence report. Katie Nichols from MITRE, she wrote a blog post that's referenced down there at the bottom, and this is taken from that, right? And so just to kind of show an example, we see that there's a lot of information here. We see, for instance, 4113.pdb. We see that there's SCH tasks with a command line. We see cmd.exe/c who am I. A lot of times we find that students or clients or just people in general that are building detections focus on those very like specific details when they're building detections, right? So like maybe I want to look for SCH tasks being run with like /create in the command line or something like that. Or maybe I want to look for this bad IP address 192.157.198.103, right? Or these specific ports 1913, right? So we see people that are building those, but ultimately what we want to do is we want to treat this as a narrative that's just giving us concepts, right? And so what Katie does in her blog post is she really like kind of builds out and says, you should read this narrative, and as you're reading it, say, how does this relate to different attack techniques, right? And so I assume most people are familiar with the MITRE attack framework, right? So these techniques that are being referenced are all techniques from attack framework. And so, for instance, instead of SCH tasks, let's look at it as, the scheduled tasks technique, right? Because they're not limited to just using SCH tasks.exe to build, to create scheduled tasks. They can use PowerShell. They can use a third-party binary. They could kind of do whatever they want, right? And so we want to kind of get an understanding of what techniques the attackers are using, and then we want to go from there. Okay, so in our training class, we kind of have a similar situation where we present them with a fictional threat report. They read through it, and then they pull out the different techniques that they come up with. And so this is kind of an eye chart on purpose, but this is Attack Navigator, which is just a way that MITRE provides to kind of represent the different techniques. And so everything that's highlighted in purple are what we expect the students to be able to pull from that threat report, right? And so in this case, and basically the reason why we really want to focus on the threat report is because the lab is recorded, and we want them to be looking for things that they're probably going to find real bad stuff in the lab, right? And so this particular team chose remote services as their technique that they wanted to look at, and then they wanted to start building a detection, right? And so the first thing that we like to do is kind of point you to the attack framework and say, okay, well, you want to look into remote services? Let's go see what MITRE says about that, right? And so this is just a really good starting point, probably not comprehensive, but it just gets you an idea of what's going on. And so what they actually say is, hey, remote services is used for lateral movement. And what they say it is attackers end up using legitimate credentials to access these services that are meant for remote administration. Things like SSH, Telnet, WMI, RPC, Windows Remote Management, those types of things. attackers are just connecting to those and being able to run some sort of task on the remote system for lateral movement, right? And so, as you're reading through that, one of the best kind of most overlooked features of MITRE ATT&CK framework is this data sources piece, right? And so that's them giving you a hint of maybe where to start, right? So you want to detect remote services. Maybe the place that you should start is looking at authentication logs. This feature of the ATT&CK framework is not like the most comprehensive or full featured, but it's just a kind of a good starting point. So if I were to ask somebody, hey, I want to look at Windows authentication logs, can anybody help me figure out like where's the first place that you would think to look? Active Directory. So that's kind of the thing that manages endpoint logs. Yeah, so like the Windows event log. Anybody know what event log is, like kind of the canonical 4624, yep, so 4624. And so this, again, probably not the easiest thing to see, but 4624 is an account was successfully logged on. And so just walking through their process, right, they said, okay, well, we want to go into Kibana, which is where our data was for this exercise, and we want to look at 4624 events, right? So let's go ahead and check that out real quick. Okay, so this is what they were presented with. There's 1.1 million events. Whether that's realistic to your environment, I don't know, but just kind of work with the thought process here. And so what they did is they decided to search for event ID 4624, and they came up with 3,859 events. In real environments with clients, that could be millions or hundreds of millions different events. But even so, 4,000 events is not something that I'm going to go through one by one and start looking through it, right? That's still too much for me to kind of go through. And authentication in and of itself is a normal feature of like an operating system, right? So there's nothing malicious here yet. And so what they did is they started looking around, and you could kind of dig into this, and it may be somewhat difficult to see, but you could start to look at the different fields that we have, right? And so one thing that they keyed in on based on their experience, let me find it here, was this logon type field. Anybody familiar with the logon type? Yep. So the idea of logon type is it tells you like what's the context that the logon happened in. So like there's interactive logons, which is where you're interacting at the actual like console, right? There's network logons, which is where you're doing a connection over the network. Remote interactive logons, which would be like RDP, something along that lines. And there's quite a few different ones, right? And so what they decided to look at was where logon type equals 3, which is that network logon. Remember, we're thinking about remote services. That kind of leads us to think about network logons. And so that's where they ended up going. So just to kind of reiterate, we're at about 3,800, 3,900 different events. And they decided to add logon type 3 to their query, and they went down to 3,200. And they're like, well, that doesn't really narrow it in. Also, like, just because somebody logs in over the network doesn't mean that it's necessarily bad, right? So like one example of a benign network logon event would be when you mount a share from like your share drive, right? So that's not necessarily indicative of bad behavior. And so they're kind of like, okay, well, what's the next step? Well, in the fictional scenario that we provided them, we said, hey, one thing that we should be worried about is that that you should be aware of as like a detection engineer within your company, this fictional company, is that every system has a shared local admin account, and that has the same password, right? And it's called test admin. And so what they did is they said, okay, at first our focus of our detection was to detect remote service abuse. But now, like, based on what we found, we want to kind of narrow in our focus a little bit, right? And this is a really good strategy a lot of times is say, hey, I'm going to make an assumption, but I'm going to document that for future reference, right? And so their assumption was, now we want to look for the abuse of the shared local admin password in a remote services context, right? And so they went forward and they specified, hey, we want to see where logon events are happening over the network, this logon type 3, and the username is test admin. Okay. And so by doing that, they came up with 16 hits, right? And so this was the point that the students, they kind of called me over as the instructor and said, hey, like based on what I've learned over the past 3 days and my experience in this lab environment, I've identified that this is bad, right? But like I can't explain to you why why I got to where I got, right? Like why is this bad? Like, I can't really explain that to you. So like, I'm missing some sort of context that allows me to definitively say this is in fact bad, right? And so this is the point at which I kind of told them, like, we need to take a step back and start to understand what the data is that we're dealing with, right? And so one of the things, this is where we're going to, from like, we have detection engineering, right, which is where you're building detections in a robust manner, you're documenting those, that type of thing. And then we have data engineering, which is where you're understanding the data or telemetry that you have available to you and how it interconnects and how it relates to one another, right? So Windows event logs, there's hundreds or thousands of events. Those different events can be related to one another in different ways. And so what we did is we started looking at one of the projects that one of our former colleagues made called OSIM. And what he does is he goes through and documents all the different data that can be ingested. And so this is Windows security events, event ID 4624, just as an example. And he comes down and he starts to say, hey, what's the description of this event? And this is just a really good practice in general. So if you're running a SOC, a lot of times we go to a SOC and we say, hey, what data do you have? And the analysts say, I don't know, we have like Windows event logs and we have, proof point logs and we have sysmon or whatever. And I'm like, okay, well, like, what Windows event logs do you have? And they're like, I have no idea, right? And so what we try to work with them on is like, hey, let's actually start documenting this in a very like intentional way. And so what we come down to is, okay, well, we have 4624 events. Here's kind of like an understanding of what this is. And this really helps our junior analysts, right? So like, there's always a guy that knows everything about everything and all the data that you have. But that person is not sharing that information in a like repeatable way with the entire team, right? So we want to raise the bar of kind of like, what's our most junior person? So that they have all the information they need, right? So we come down and we start saying, what are the different fields that this event has? So there's like a subject user SID, target user SID. There's a logon type field, right? We saw that. There's a workstation name. There's a logon GUID, so on and so forth. And we're actually like documenting the entire part of the process, right? And kind of going through. We also have, for instance, we can go and check out the Microsoft has a GitHub page that kind of keeps track of this as well. And so they go into what does it look like in the XML format that you would be receiving it at your SIM. They also actually describe in detail every single field that's in the event, right? And so we could start to leverage that and understand. And so to go back, let's say you didn't know what the logon type thing was, right? And that I talked about. You come here and it says, hey, logon type is the type of logon that was performed. Here's a table that tells you all the different types, right? So type 2 is interactive, user logged onto the computer. Type 3 is network, so on and so forth, right? So you're able to kind of like get into that and start understanding it. Okay. All right. So one of the things that that as we're going through this, that we identified, I'm trying to find it here. Okay. So we have the user logon ID. And so what that ends up being is, this is kind of like an understanding of Windows internals a little bit, but when you log on to a system, there's what's called a logon session that's created, right? And so every logon session has what they call a locally unique identifier, or LUID, and that represents that logon. That's like the identifier for that logon session. 4624s have that information, and what we could actually do if we've documented all of this stuff is we could take this name, user logon ID, and we could actually search through our repository, and we can start to see all the different events that have user logon ID, 4799, 4662, 5377, and we could click into these and start to learn more about them. And an account was logged off, 4634, right? And that has a user logon ID. And so what I told them was, hey, we have these 16 events. What happens if we take the user logon ID that's associated with it, and we actually just kind of search for that, right? So again, we have, not IT. Kibana, of course, puts commas in the output, but you can't have that in the actual query. And so we end up having 3 hits, right? So these are basically all the events that are related to this user logon ID. We have a 4624, right? So that's that logon event. We have a 4634, which is a log off event. And we have a 4672, which again, we would be able to come in here, search for 4672 because we've documented this data. And then we would be able to see what that is. What that ends up being a special privilege was assigned, which every logon is going to have that event associated with it. Okay, but we don't see any additional context that might be interesting. You may see that I have this command line field highlighted over here, so that might kind of tip my hand at what I'm looking for. But as we kind of go through these, and notice I'm doing it very manually right now, kind of on purpose to demonstrate the point. We run that, and we have a different event that pops up for this specific logon session, right? That's a 4688. Does anybody know what a 4688 is?
Process creation.
Yeah, a process was created is the name of it, right? So, does anybody see anything that might be worrisome to them if they were to come across this?
No.
No, yeah, of course Matt Graver says no. Yeah, so, okay, so, I mean, the most obvious one, I think, is probably this PowerShell with an encoded command. Maybe what I would do is, come down here. I mean, this is what it really looks like, right? So I don't know about you, but I don't type that in myself typically when I'm administering systems. But you could go and decode this and go see what's actually happening. Some other things that you might look at are like who am I, which is kind of something that an attacker might use for situational awareness to know what user they're operating as. They're doing some sort of group enumeration, domain group enumeration for domain computers. And so that's starting to look like something that's suspicious, right? And so then we kind of I only have 25 minutes, so we're not going to go through each one. But basically, we went through all 16 and we said, hey, what context can we pull from all of these, right? And so they said, hey, that's really awesome. We were able to document our data, understand the connections between these different data points, and then we were able to start to add context. The problem is we did that manually, right? And it was kind of a pain in the butt when we did it for 16, but in a real environment, there may be thousands or hundreds of thousands, right? So I'm not going to do that kind of in a manual way, right? So what we end up having, I'm going to go back to the slides and skip a few. We end up having a situation like this where we end up seeing a user authenticated to a host. We're building all these connections. That host had a process that received that connection. It ends up spawning a process called WMI-PRVSE. Then there's this logon session that's created. And then a process, a nondescript process. We don't care what that process is, but we just care that there's a process that's associated with this type 3 logon session, right? And so again, we have this 4624. One thing that we really like to look at is this concept of a Windows event log is really just a storytelling device, right? So really, I look at it as, what can I get from this? So a lot of times we look at it as a unique entity, like this is a 4624, but really there's quite a few different concepts that are really at play inside of the 4624, right? So this is kind of what I end up looking at. So a 4624, I create a data model for it in my mind, and so we have a source computer, right? That, in context of a type 3 logon event, we have a source computer. It authenticates to a target computer, right? So that's what's happening. That target computer creates a target logon session, and then that target logon session is running as a target user. So whatever user logged on to that destination or target computer, right? Similarly, we have a 4688, and that tells us a process created a new process. So think of this as the parent process. This is the child process or the process that was being created. Those processes are running on a computer. We have a subject user who is basically the parent, the user that was running as the parent process. And then we have that new process, the child process. It's associated with a target logon session, and it's also running as a target user, right? So that's the context that this is telling us. One problem is the 4624, let me go back up here, that doesn't give me any context about what that logon session was doing, right? So how do I differentiate using just a 4624? How do I differentiate somebody connecting to a network share from somebody that's running a PowerShell encoded command, right? Or who am I, and doing a bunch of post-exploitation type stuff. The other problem is, for 4688, that's just telling me the context of a process. So how do I actually differentiate between or a process that was created as part of a type 3 logon session, right? So this is where we were doing that manual process to go back and forth and copying that logon session ID, right? Okay. So so again, was this logon session created via network logon? Well, 4688 doesn't have that context. And one of the things that we run into, especially within like Kibana, for example, is Kibana is not super great at like relational. It's a document Elasticsearch is a document database. It's not real great at like building relationships and allowing us to query for those, right? So we're able to look at 4624s. We're able to look at 4688s, but it's relatively difficult to be able to look at both of those in the same context to try to build relationships. Okay, and so what we end up with is trying to build out this like greater model here, where we have a source computer that authenticates to a target computer, right? So we'll just say there's an IP address called 192.168.1.5. It connects to a system called target.local. Target.local, it's connecting as domain/attacker. So domain is just the domain name, and attacker is the attacker name. And there's a logon ID of 1337, and there's a logon type of type 3, right? And so that's kind of the extent of what I'm really gleaning from a 4624 event, right? So we have a logon type 3, we have a logon ID, we have the user, we might have the system that they were being connected from. But then we also kind of like on the second half of this image, we have 3 processes that were created. And those 3 processes, we're getting information about them or context about them from 4688 events. And so, for instance, we have PowerShell.exe, who am I, and net.exe, which is what we just saw in Kibana. And those are being created, but they're also telling us, hey, these are part of the 1337 logon session, right? So now I'm thinking, okay, well, like this is what the student was really asking me. It's like, hey, I did all this manual stuff. It's really awesome. It's kind of cool to be able to make those connections. I learned about logon sessions and and processes kind of residing within a logon session. But like, how would I do this in production? Like in real life, I can't just go one by one and check each one, because we don't have the manpower to do that. And so really what they were asking is, how do I add that context, that logon type 3, to these process events, right? And so, what we're using here is anybody familiar with the Helk project? Yeah, so Elk is Elasticsearch, Logstash, and Kibana. Helk is basically a flavor of Elk that's built for threat hunting like use cases. And so one of the things that it has is an Apache Spark backend, which is just allows for like distributed computing. So you could run a query across a number of different nodes and try to like increase your computational performance. And it also has the ability to do Jupyter notebooks. And so, oh boy, that might not be good, but we have the result. Okay, so let me zoom in here. Okay, so this is called Jupyter Notebook, and this is just a way for us to like kind of save off different queries that we're making. So we could make a series of queries and like kind of save that off so that it could be repeatable and that type of thing. And so there's this capability called PySpark, and there's Spark SQL that allows us to actually run SQL queries across the data that's in this Elasticsearch database, right? And so at the beginning, what we're doing here is we're just kind of like setting up a Spark session, which allows us to like do that distributed computational workload. And then we're going to basically reach out to our Elasticsearch right here, right? And we're basically trying to connect to it, right? From there, we have this index, so the logs endpoint Windows WinEvent security index, which is where our security event logs are stored in Kibana. Let me just kind of show what that looks like here. So in Kibana, you have a bunch of different indices. For instance, we have a sysmon index, we have a Windows security event index, we have a PowerShell event logs index, system index, so on and so forth. You could have like a network, like a bro index, so on and so forth. Okay, so we're really only interested in this Windows security events. So then what we end up having to do is kind of like basically ask Spark to pull from that index the events or the data that we're interested in, right? So we basically are saying, hey, we want to select, and so anybody familiar with SQL should be somewhat familiar with this, but we want these properties, so event ID, host name, source IP address, user logon ID, username, logon type, and timestamp from security events, right, which is basically all the events that we pulled out. Where the event ID is 4624, so our logon event. The logon type is 3, so a network logon. The source IP address is not null, so we want to be able to tell where that event was coming from. And then we just have a timestamp to narrow in on specific data for the use case here. Okay, so we run that, and that ends up giving us back all those events, right? And then we basically do the same thing for 4688s. We're interested in host name, parent process command line, process name, process command line, username, user logon ID, so on and so forth, where it's 4688 here. Okay. Then we store those kind of in a variable here. And now what we do is we actually do a join, like a SQL join across these events. And we end up with user logon ID, basically where the user logon ID from 4624 is equal to the user logon ID from 4688. And just to kind of show, it's not an instantaneous process here. But this goes forward, and it's actually kind of like running our query on the back end. Okay, maybe that might have just messed everything up. Before I did that, did everybody see that there was output there? Okay, oh, good. Okay. All right, let's see if this. Okay, that's a good sign. So this will show how long it actually takes, just so that there's. Okay, so this is the part that takes a little while because it's doing that kind of like correlation there. And basically, what we're trying to output is just show me every 4688 event that is spawned from a logon type 3. That's the general idea, right? Because we want to see that. Now, when we're going through this process, a 4688 event is not necessarily, or that's spawned from a logon type 3 is not necessarily bad, right? So, like a situation I could think of is maybe you use Altiris or some sort of other, like system management type tool or like vulnerability assessment type tool, and it's going out and running these remote commands on systems. That's going to be, benign in this use case, or a false positive. And so you would have to kind of like go through and figure that out. But what we end up seeing, and this is from a different data set here, but we see that this P. Gustavo user ended up spawning net.exe, right? Or from net.exe, they spawned conhost, and then they used net1.exe, right? So, and then added a user called backdoor with a password of PAW0RD1, right? So the funny thing is this is from the Mordor project, and the Mordor project is based on Roberto. His dog's name is Pedro. P. Gustavo is Pedro, and so Paul is his dog's paw. Anyway, so that's generally the idea of how we would go about doing this in an automated fashion to be able to build those correlations based on understanding our data in the first place. Cool. That's all I have. If anybody has any questions, I'll be outside afterwards to chat about it.